Okay, so we're going to have a quick review of partial fractions. So you've got an information sheet showing the four main different cases. So I'm just going to go through a few of these with you. I want you to try and do some yourself before I give you the answer. So the first one, x minus 1, x minus 3 over x minus 1. So all I want you to do first is fill in the column that says the form of the partial fractions. So the degree of the top is 1, and the degree in the bottom will be 2. So if I expand it, I'll get an x squared. So therefore, the top degree is less than the bottom degree. So that's just the normal, straightforward, easy case. So it will just be a over x plus b over x minus 1. Okay, the second one, we have 21x squared take away 13 over x plus 5, 3x minus 1 squared. So the degree of the top is 2, and the degree in the bottom, if you expand that bracket, you get x times 3x times 3x, so you get x cubed. So the degree in the top is 2, degree in the bottom is 3. So again, it's the same as before. It's a straightforward case, but I don't have to worry about improper fractions. However, this time, there's a repeated factor. So I would have a over x plus 5 plus b over 3x minus 1 squared. But I need to remember when I put squared, I need a term without the squared. Now, when I've written the answer here, I'm not sure about how I've done the same order for the A, B's, and C's. No, it doesn't matter. I've just done it like this just because A and B are going to be easy to figure out. So the ones on top of the x plus 5, 3x minus 1 squared are going to be the easy ones. And to get C, to figure it out, you're going to have to sub in a random number. Okay, third one, 2x squared plus 2x minus 3 on top. So the degree is 2. And on the bottom, if you expand the bracket, you'll get an x squared. So the degrees are equal. They're both 2. So it's an improper fraction. But if they're equal, this is where we can use the slightly quick case. So I know that there's going to be a number at the front plus something over x plus 3 plus something over x minus 1. Okay, the next one. X cubed, take away x squared, take away x, take away 3 on the top, so the degree is 3. And on the bottom, I'd have an x squared, so therefore the top is higher than the bottom, 3 is bigger than 2, so it's an improper fraction. So the top is x cubed, bottom is x squared, so the difference is 1. So I would have my quotient, remember, my quotient is the bit on the top of the grid, so if I do the grid method, and divided by x minus, or x squared minus x, whatever it was, this top bit here is like what we call my quotient. My quotient will be degree 1 polynomial. So that means it'll be something x plus something without x. And then I would have partial fractions in the last bit plus c over x plus d over x minus 1. Next one, x squared plus 1, which are randomly put in brackets, and on the bottom, x minus 2. So x squared on the top, and when you expand the bottom, you get an x squared. So the degrees are the same. So think about what the form should look like for that one. It's one of the four we've done already, because I've done all 4 different types. So it should look like that. A number plus something over x plus something over x minus 2. Okay, the next one, minus x squared minus 10x minus 5. So think about the degree on the top, x plus 1 squared, x minus 1. So think about in the bottom, and see if you can write down what type, what form of partial fractions it would be. And it's one we've already talked about. It will look like that. Same for the next one. Can you write down the form it would look like? And the last one, have a think about what the form would look like. Good. Okay. Okay, now we've got that column filled in. The next thing I want us to do is fill in the next column where we actually work out what all those missing letters are. So I'll just do a couple of them with you. In particular, first four, and you can do the last four yourself. So for that first one, I'll do this one in detail so you can see how it works, remember, in case you've put in. So we have x minus 3 over x minus 1 equals a over x plus b over x minus 1. Right, now this is the step that we normally don't write out. So I'm going to times, I'm going to get rid of the denominator here. So times both sides by the bottom. So after times a by x minus 1, so I put a bracket there. So it's still over x. I'm going to times b by x minus 1. I've got x minus 1 at the bottom. The x is cancelled out there. The x minus 1 is cancelled out there. So we're just left with a times x minus 1 plus b times x. So sub in two numbers. So if I sub in 1, I get rid of this bracket. So I get minus 2 equals 1b. So b is 2 minus 2. And if I sub in b is x is 0, I get minus 3 equals, well, that's minus 1, so minus a. Therefore, a equals 3. So a is 3, b is minus 2. Yeah, that bit I think you're happy with. The second one, I'm going to times by the denominator, and I'm going to get a times, well, the x plus 5 will cancel out, so just get 3x minus 1 squared, plus b times, well, one of the 3x minus 1s will cancel out, so I've got x plus 5 left, and 3x minus 1 left, plus c times the fourth 3x minus 1 will cancel out, so it's going x plus 5. Okay, so first of all, think about what the magic numbers are. So I've got x is a third, so I'll get rid of that bracket on that one, so I'll just get c. If I stick a third into there, I'm going to use that calculator on now. So it's 21 divided by 9, take away 13, which gives us minus 32 over 3. Third into there, like I said, becomes 0, 0, and the third plus 5 gives me 16 over 3 times c. Then just solve out what c is, well, times both sides by 3, divide by 16, so c is minus 2. My next magic number would be minus 5. So 21 times 25, take away 13, I get 5, 12. 5 into that, minus 5 into there will disappear, minus 5 into there will disappear, so I just get there. So minus 5 times 3 is minus 15, take away 1 is minus 16, square that, I get 256, so 256 there, divide by 256, so I get a is 2. And then to get my missing one, to get my b, I just pick a random number. So if you have any 0, 0 is the easiest. So I get minus 13 on this side. Here, if I sub 0 in, just get minus 1 squared, so just get 1a. 0 into here, I get 5 times minus 1, so minus 5b. 0 into here, I just get 5c. Sub the numbers in, you know. So I know a is 2, don't know what b is, I know c is minus 2, that's minus 10. Rearrange it a little bit. So minus 15, minus 5, so minus 5 is minus 5b, therefore b is 1. I've got my 3 numbers, let's check that they're right, that I haven't done something stupid. Good. Okay, next one. So I'm going to times by the bottom to get 2x squared plus 2x minus 3. This is a times x plus 3x minus 1. That's got nothing to cancel out. Here the x plus 3 will cancel out. And here the x minus 1 will cancel out. So pick your magic numbers. So x is 1. 2 up 2, take away 3, so that's 1 equals 1 into there, disappear, into there, disappear, into here, I get 4c. So c is a quarter. X is minus 3. So minus 3 into there, but just calculate again, 2 times 9, 9 equals minus 3 into there disappears, that's into there, minus 3, take away 1 is minus 4, so minus 4b. B is minus 9 over 4. Now to get a, this is where there's two ways. So I can either use the trick where if I look at the original fraction, if I just look at the x squared terms, I'm going to have 2x squared divided by x squared. So in my gridlock, I have 2x squared on the inside, on the outside I have x squared, and the other term would be, well, the rest I would have 2x minus 3 down here. My first term up here would just be a 2. X squared times 2 gives 2x squared. So a should be 2. Now, if you don't like that method, then you can just pick any random number. So again, if I pick 0, that should work. So minus 3 on the side. Here, I get 3 times minus 1, so I get minus 3a. Here, I get minus b. And here, I get 3c. Put the numbers in. Minus b plus 9 over 4 plus 3 over 4. Well, 9 over 4 plus 3 over 4 is 12 over 4, which gives me 3. Take it to that side, so I get minus 6, minus 3a, therefore a is 2, like I said. And just to check if we've got the right answers. Good. Now, just before I do the next one, remember something like that second term, the minus 9 over 4 x plus 3. I could write that as minus 9 over 4 lots of x plus 3. The only reason I'm leaving it like that, and the answer is because in tomorrow's lesson, we're going to start integrating that. Okay, and last one I'll do with you, the fourth one. So to do this, well, if the top degree is higher than the bottom degree, I could, that same method where I times it by the bottom, sub different numbers in for x and get simultaneous equations, but it's going to be a nightmare. A quicker way of doing it would just actually be do the long division this time. So I'm going to do x cubed minus x squared, take away x, take away 3, divide by x squared minus x. So I'm going to do a grid, x squared minus x down the side, x cubed goes in it, x squared times x, x times minus x squared. I wanted a minus x squared, so I want 0 x squareds there. So my next thing I want is a minus x. Well, that can't be done, so this must be my remainder, and minus 3. Yeah, that's a bit confusing for you actually. Let me write the 0x squared in, that might help. So I want 0x squared because I want these two to make minus x squared. So x squared times something is 0x squared, so that's plus 0, which gives me minus 0x. Now, remember, as soon as I hit number, I need a remainder column. Now, I want minus 1x, so I need a minus x there. And I want a minus 3. So this thing equals x plus 0, which I'm not writing, plus minus x minus 3 over x. I'm going to put the factorized form back in. Now, it's this last bit here that we're going to do partial fractions on. So I've got the x that's set. It's this that I'm going to do partial fractions on. So we'll group this working out. So minus x minus over x, x minus 1. So I've written in the question already that I want that c over x is d over x minus 1. So times it by the bottom, so you get good at this bit. So my equation becomes, I just need the room, minus x minus 3, c times x minus 1, and d times x. Sub in your magic numbers. So 1 minus 1 take away 3 is minus 4. That'll disappear. That is just d. So I've got d straight away. And then my other magic number is 0. So that is x plus 0. So sub into there, I get minus 3. Into there disappears. Into here, I get minus c. Therefore, c is 3. C is 3. D is minus 4. And I've got my quotient, just x and 0. Yeah, so if the top power is bigger than the bottom power degree, then definitely do polynomial division. Yeah, otherwise, if you really want to, I'm going to show you that the other way would still work. It will be a bit longer. So what you would have is you would have the top equals ax plus b times by x times x minus 1 plus c times x minus 1 plus d times x. So when you sub in 1 and 0, you'll get c and d. But in order to get a and b, you need to sub in two different numbers for x, get two simultaneous equations, and solve them. So personally, I think the grid method was much quicker. Okay, now it's your job to finish the rest off. So pause the video and do these four, and then unpause it and check your answers. And then tomorrow we'll integrate these. Make sure you've got your A answers somewhere safe, ready for tomorrow's lesson.